a lot of review just in context of word problems. So the first question here says a cube has a side length of x plus 4. Things we know about cubes. When you have a cube, it means that all sides are the same. So this is x plus 4, and this is x plus 4, and this is x plus 4. All sides are x plus 4 if it's a cube. If that's not the case, then they'll tell you, right? They'll always make it clear. The question says determine the area of one face of the cube. So face means one side. So if you were looking at this and you wanted to figure out what's the area of just this side of the cube, you're actually looking for area of a square, right? And the area of a square is equal to what? What's the formula? Area of a square, the formula, I know, I believe in you.
Length times width.
There we go. Believe is a power. So it's length times width. So if you were to look at this square right here, and you wanted to know length times width, all the sides are the same, right? So then you're just doing x plus 4 times x plus 4. So area equals x plus 4 times x plus 4. It's the same thing, right? The square, both sides are the same. That's fantastic. That'd be like, I don't know, maybe a half mark if I was feeling good marking your test. The only reason it would only be a half mark is because I would want you to do what to that? Yeah, actually answer it, actually multiply it, right? So actually multiply these two binomials together. We have two methods that we've learned. What are they? The FOIL and the area diagram. So you can do either of those methods. You can distribute or you can area diagram. It's your choice. I'm going to choose to area diagram it and show my answer on the board. If you really prefer something else, like if you prefer FOIL or if you prefer distribution, then you could do that as well. Just a reminder of how an area diagram looks. You take the first binomial, you write it across the top. And it's like you're creating a little chart. You then take the second one and you write it down the side. And what you've done is you've created this little grid. And you have to fill out the inside of that grid by multiplying the row and the column heads. So if I had an x times an x, that would create x squared. If I had an x times a 4, that would create 4. If I had a 4 times an x, that would create another 4x. And the last one would be 4 times 4 is 16. Watching you guys work last week, sometimes we're forgetting that we're multiplying to get those insides. But you're always multiplying to get all the inside squares, especially the last one. A lot of people put 8. Right? Remember, it's 4 times 4 for the last block, not 4 plus 4. You're always multiplying. Once you've filled out the inside of your grid, what do you do with it? Yeah, you're going to simplify it by writing it all out into one long string. So I have x squared plus 4x plus 4x plus 16. That's all the numbers on the inside of that grid. And I'm going to look for like terms. So that means the same letters, same exponents. 4x and 4x are the same letter, same exponent. So those two can be combined. If I have 4x plus 4 more x, that would combine to be 8x. It would only be 8x. And we don't add the exponents because we're not multiplying anymore. We're collecting like terms. What helps me distinguish between the two things is trying to remember like what I have. We could actually do a picture with this, right? Remember those algebra tiles? And an x, that was a long, skinny algebra tile. So this means I have 4 of those, and I have 4 more of those. So I wouldn't all of a sudden have 8 of the big blocks, right? Which is what next square was. I would have 8 of still the skinny little guys. So it would be 8x. And that's where those algebra tiles come in handy, is remembering that x is an actual thing. So if I'm adding them together, it remains as an x, not an x squared or an x cubed or anything crazy like that. Why can't I combine this x squared and this x?
Powers.
Yes. Coefficients are the same, that's okay, but the exponents are different. And if the exponents are different, then you can't bring them together as like terms. Awesome. Part B. Determine the volume of the cube. Does anybody remember the formula for volume? Beautiful. So volume equals length times width times height. We know in a cube that all those things are the same. They're all x plus 4. So I'm going to change them all to be x plus 4. Notice that I just put brackets around them and have brackets against brackets. That means multiply. So I don't need to write the multiplication symbol. You can if you want. If I have 3 sets of brackets like this, 1, 2, 3. Who remembers our strategy on how to figure out what those equal? Never. Oh. Is that a hand up or no? No. Bingo. You're going to take the first 2 and you're going to multiply them like it's a separate question. And then you're going to get an answer. And then you're going to multiply that answer by the last one. I already know what x plus 4 times x plus 4 is, don't I? We already did that part of the question. That was x plus 4 times x plus 4. So I can just kind of skip a step and put that in there. The other x plus 4 we haven't used yet. So I need to leave it on the side. To multiply a trinomial by a binomial, that's what I have here. I have 2 options. I can do distribution. So I can take this and distribute it to everything in the brackets. And take the 8x and distribute it into the brackets. And take the 16 and distribute it in. Or I can do an area diagram. And I think most people in this room are leaning towards area diagrams lately. If you want to do distribution, you're not wrong. That's fine. You should always get the same answer. But if you're liking area diagrams, that works for me. Because you guys are doing area diagrams so much, I will also do area diagrams so much. So if I set up this as an area diagram, I take the first one, I put it across the top. I then take the x plus 4, I put it down the side. And I've created a little grid with 6 spots that need to be filled in. I go x times x squared from x cubed. You add the exponents. I go x times 8x is 8x squared. And I go x times 16 is 16. Across the bottom, all you do is multiply everything by 4. So that'll become 4x squared. That'll become 32x. And then that'll become 72. No, 64. Holy man. So I figured out all my blue numbers on the inside. If you have to use a calculator for that, that's fine with me. I would definitely use a calculator to be sure. I don't have one on me. Doing the area diagram, that's fine. That's good. That's nice. This isn't a final answer, though. What do I have to do with all those blue numbers I created on the inside?
Simplify.
Simplify. And you simplify by writing them into a nice long string, right? So I'm going to have x cubed plus 8x squared plus 16x plus 4x squared plus 32x plus 64.
You can skip that.
You can skip that step.
That's what I'm doing.
Yeah, that's fine. If you can look at this and realize that certain things can combine, so if you looked at that and you were like, oh, this and this, that's good. If you have to look up here and do it, that works too. Like for me, I like to write it all out, and then I look for my like terms once I've written it in one long string. So I'm looking for the same letter, same exponent. My same letter, same exponent would be my 8x squared and my 4x squared, and my 16x and my 32x. So I underline them. I've done them in different colors so they stick out. The other things are not underlined because there's no other x to the power of 3's in the question, and there's no other constants in the question. So if I was to combine these like terms, I'd have x to the power of 3 plus 12x squared plus 48x plus 60. And that's as much as I can combine because you have different exponents on every single letter now. Anybody have any questions? Alright, let's do the next one. So another word problem that you'll probably run into is one like this, where it says, determine the area of the shaded region. So if you look at this, you have you have one rectangle and one square. You got this big one in the red. You got this little square in the green. They want to know the area of just the shaded region. They want to know the area of almost the entire rectangle. Almost the entire rectangle. But what don't they want to know? The little hole in the middle, the area of that square. So what would be a good way to figure out the area of the shaded region?
Can you just like do like a little figure out how much it is needed and subtract stuff?
Perfect, what you would do. You would figure out the area of the rectangle. That would be everything. And then you're going to subtract the area of the square. That's exactly what we're going to do. So if you want to figure out just the region around the outside, then you need to do all of it and subtract away this little chunk. We don't have any mathematical way to do this and then this and then this and that. Like, we don't have any formulas for that. There's no formula for area of a donut. A lot there is, but not this donut. Now, basically, you have like 3 separate questions, right? Question 1 is, you have to figure out area of this rectangle. Question 2 is, you have to figure out area of the square. And then question 3 is, you need to bring them together and separate them from each other. So we're going to do area of a rectangle first. The rectangle was 3x minus 2 times 2x plus 4. I'm going to do it on the side over here in a little area diagram. I want you to also try a little area diagram or distribution, your choice. So go ahead on your own, see if you can get the same answer as me. And you can compare your results with mine. If you use distribution, you should get the same answer. So the area of the rectangle, I did in the red on the side. No matter what, you should have got these same 4 numbers at some point on your paper. So whether you did distribution, or whether you did FOIL, or whether you did area diagram, you should have ended up somehow getting a 6x squared, a negative 4x, a 12x, and a negative 8. Make sure you're multiplying. So if you're not getting those numbers, odds are you probably added by accident. You added your coefficients. Make sure you're multiplying. Also make sure your negative was used. It's a negative 2 that you're multiplying by everything. The next step would have been to write them all out and combine any like terms. These are your like terms. So you have a 12x and a negative 4x. That would add together to be 8x in the middle term. Alright, now that we know the area of the rectangle, now you have to figure out the area of the square. That's x minus 1 times x minus 1. So, on the side of my paper, I'm going to do that one a little quickly. So x minus 1 and x minus 1. That gives me x squared, negative x, positive 1. Combining like terms, it's x squared minus 2x is plus 1. So I'll give you a second to write that down. Just kind of speeding through that. Again, you can use whatever method you want for those questions. I highly suggest you use a calculator, especially with negatives. Makes your life a little bit easier. Now that I know what these things are, I'm going to put them back in my big formula up here. So my area of a rectangle is 6x squared plus 8x minus 8 minus x squared minus 2x plus 1. Notice that I put my answers in brackets. The brackets are actually going to make a difference in this question. Why are the brackets, especially on the green one, going to make a difference? Right, so that the x squared isn't the only thing that's negative. If you didn't have brackets, then it would look like negative x squared minus 2x plus 1. Instead, we put brackets so that we know that what does this black negative mean we have to do? Subtract everything. And if you're subtracting everything, it means it changes all the symbols. So you have to change the middle symbol to become a positive. That changes the x squared to become a negative. It changes the negative 2x to be positive. And it changes the positive 1 to be negative. Remember, negatives change all the symbols to the right. Once you've done that, the brackets go away. Once the brackets go away, you can start to combine your like terms. So I have a 6x squared minus x squared, that's 5x. I have an 8x plus a 2x for positive 10. And I have a negative 8 minus 1 for negative 9. That's the area of the shaded region. You are definitely going to have to do something like that. I'll give you a minute to do a little bit of copying. I know there's a lot there. A lot of little tricks, right? Like remember how to multiply, remember how to subtract something and stuff like that. A lot of little things. You got to remember the exponent laws and so on and so on. Anybody have any questions about finding the area of that shaded region? Where I got a number from? Why is it something like this? Why is something like that? All right. Okay, we have one more word problem ahead of us. It's another one that you're going to see again. Okay, so it'll pop up again. It's an L-shaped format. Right? So it's something that looks kind of like that. They'll call it a polygon. Polygon just means something with many sides. Right? So every shape is a polygon. But if it's not a shape that we know, like there's no special name for it, like I wouldn't call this a cylinder. I don't have a special name for an L shape. They just call it a polygon. The first question is, find the area of the polygon. Well, I don't have a formula to figure out area of an L-shaped thing. All I know is how to find area of squares and rectangles, right? Like times width. So I need to look at this and somehow use what I actually know. What I'm going to do is I'm going to cut this thing in half. By cutting it in half, I'm creating two rectangles. I'm creating this one in the red, and I'm creating this one in the green. Why is that beneficial to me to have two rectangles?
Now you can do the equation because you have to do rectangles.
Exactly. I can figure out the area of the red rectangle, right? I know how to do that. And I know how to do the area of the green triangle, or rectangle. Ooh, not triangle. And then once I have two areas, what can I do to them? Add them together, and you got the whole thing. So that's what we're going to do. We're going to add these two areas together. We're going to go area of the red and we're going to add the area of the green. That's how we're going to solve this question. But you have to break it into two separate areas. Area of the red, the formula would be x times 2x minus 1. The area of the green would be 3x plus 2 times x plus 1. And that's a question that's straight out of like 2.3, I think, where you just have to do a little bit of multiplication, then add your like terms together. You can use area diagrams, you can use distribution, you can use whatever you need to be able to multiply those together. On the red side, actually, I want you to just go ahead and try. So from there forward, I want you to try to figure out this whole question. Don't worry about B or C, because I'm going to change the questions to B. But go ahead and try to finish off A. Whether you did area diagram, whether you did distribution, whether you did FOIL, your red side should have come out to be 2x squared minus x, and your green side should have had these four terms in some order. Alright, now I have this plus symbol. Notice that I put the green in brackets, because last time we changed this to be a positive and we changed all the symbols, right? You only do that if the thing in here is negative. If this is positive, it's not doing anything to this question. This question can just stay the exact same but without brackets. We only change the symbols if that's a negative in there. Because it's positive, you're good. You don't have to change anything. You can just start combining like terms. So x squares are going to go with x squares. X's are going to start going with x's. You have negative x plus 3x minus 2x positive 4x. If you're not sure, use your calculator, right? Negative 1 plus 3 plus 2. See what it equals. And our last term over here, which is plus 2. That's the solution to the area of that shape. Any questions? Alright, the reason I didn't want you to do B is we're not going to do B, so we're not going to worry about perimeter. And if you look at C, we're going to change the word perimeter to areas. So it says, if x represents 7 centimeters, what is the area of the figure? You figured out that the area of the figure was 5x squared plus 4x plus 2. When they're telling you down here, x represents 7, they're saying x equals 7. So now you could actually calculate and measure the area. Like you get a solid number rather than this big equation. To do that, you take the same equation you had, and anywhere you see the letter x, you put a 7. And you're going to put it as a 7 in brackets. And the brackets are very, very, very important. So that's how it looks when I replace an x with the number 7. I use brackets. I put it in a different color so it sticks out to you. Does anyone know why the brackets matter so much? Especially at the start of this problem. Like, yeah, instead of having, if you had no brackets here, then you would have either 57, and it would look like a 57, or you'd have 5 times 7 and then squared. But the question is, 7 squared times 5. And by putting brackets, you're making sure the squared only goes to the 7. So that's the important thing with those brackets. If you put that in your calculator, and you use brackets, the answer should be 275. If you wanted to calculate it, yeah. If you wanted to calculate it like chunk by chunk, you could do that as well. So you can figure out 7 squared times 5 is equal to 245. Plus, you can figure out that 4 times 7 is 28. Plus 2 is equal to 2. And if you add that together, it's 270. So whether you want to do it in little chunks like that, or if you want to just put the whole thing in your calculator at once, either way you should get 275 is the area of that shape if x equals 7. Any questions about that substitution?